Molecules that start with hydrogen in their formula are recognized to be acids and are named differently than typical molecules. Not all acids start with hydrogen, but the ones that do, we name differently than regular molecules, as we learned before. When you're naming acids, we know all of them are going to start with hydrogen, but it's the second part that really determines how we really name them. There's two main types of acids, those that have oxygen in them and those that don't have oxygen in them. Acids with no oxygen use the word hydro, and I've come up with the phrase, no O, use hydro. For example, HCl has no oxygen in it, so we would say hydrochloric acid. So let's analyze this. Since it has no oxygen in it, we start the word off with hydro. And then we take the chlorine and get rid of the INE at the end and put IC. And then of course put the word acid. We look at the next one, HBr. Notice no oxygen at all. So we're going to start off with hydro again. But instead of saying hydrochloric acid, we say hydrobromic acid. So we took the INE off of bromine and put IC again. Here's another one. This one is a polyatomic ion paired up with hydrogen. It's called cyanide. Since there's no oxygen in it, we still use the prefix hydro, and instead of cyanide, we use cyanic. So this is called hydrocyanic acid. If the acid does have oxygen, it depends on how the polyatomic ion is named. If it ends in ate, we replace the ate with ick. I came up with the phrase, I ate it and it's icky. For example, here's H2SO4. Notice that there is oxygen present. So we are not going to put hydro at the beginning of this, and we are just going to call it sulfuric acid. Sulfate is a tough one because we keep the sulfur in there, even though you would think it would be sulfic acid, we still continue to call it sulfuric acid, which I think sounds better. The next one, H2CO3. Notice oxygen's present again. We're not going to use hydro as our prefix. This one's called carbonate with hydrogen, so we are going to replace the carbonate and get rid of the ate and put ick. So it's called carbonic acid. Notice I switched the accent. It's not carbonic acid, it's carbonic acid. This one right here is hydrogen paired up with acetate. Notice there is oxygen present, so we will not use hydro again, and acetate ends in ate. So if I ate it, it's icky, so I'm going to call this acetic acid. Notice I took the ate off and put ick. Acetic acid is the formal name for vinegar. Let's say we had hydrogen paired up with a polyatomic ion that ended with ite, not ate. If it ends with ite, we replace the ITE with OUS. So here we have hydrogen paired up with sulfite. So instead of saying hydrogen sulfite, we would say sulfurous acid. Notice it looks exactly like sulfuric acid, except it ends in OUS instead of IC. Here's another one. That's hydrogen paired up with nitrite. Well, if it ends in nitrite, we're going to replace the ITE with OUS, and it becomes nitrous acid. Last example, if I have hydrogen paired up with phosphite, this is another tricky one. We call it phosphorus acid. Notice it's not phosphorus acid, it's phosphorus acid, because phosphorus acid sounds a lot better. So using those three names at the top, we're going to take this name and convert it into a formula. In this first example, hydrofluoric acid, we know that it's going to start with an H and there's no O in this formula. So it's probably going to be hydrogen with a fluorine. So we write out hydrogen with a fluorine. And you look at the charge on fluorine from the periodic table. It has a -1 charge. Remember that hydrogen only has a +1 charge, so we still have to make the acids be neutral. So it's going to take 1 hydrogen to neutralize 1 fluorine. So the formula for hydrofluoric acid is HF. Another one, oxalic acid. This one does not have hydro in it, so it must be hydrogen paired up with a polyatomic ion that has oxygen in it. Notice it ends in ic, and if I ate it, it's icky. So if I replace the IC with ATE, I get oxalate. That must be the polyatomic ion that it's paired up with. So if I take hydrogen and oxalate, remember that oxalate has a -2 charge. Therefore, it's going to take 2 hydrogens to neutralize 1 oxalate ion. And that's why the formula for oxalic acid is H2C2O4.